let's start. So, I think we are about to start double dual today. So, first, what was we defined a vector space. Okay. So, we have defined a vector space.
আচ্ছা তুমি কি স্ক্রিন শেয়ার করছো
Sorry.
আর রেকর্ডিংটা স্টার্ট
Hold. So, we have already defined a vector space. To this V over a field F. Two, we have defined V star the dual of V. What was V star? V star was set of all linear transform V to F, right? And if this was a basis for V, we have constructed beta star to be the basis of be a basis of V star. Now our goal is to define double dual. To define V star star double dual of V, that is the dual of V star. So V star star will be defined by vectors linear transformations from V star to F. Any guesses what it should be? So this is one of the prime theorems of this chapter. We will show we will show that if V is finite dimensional, then V star star is isomorphic to V. So, okay. Here, first of all, what they are doing is they are posing a question. We considered a basis of the vector space V, and we saw that dual of that basis was also a basis for V star, right? If V is a basis of V, beta is a basis of V, then beta star was a basis of V star. Now, a natural question should be, is every basis of V star of that form? By that I mean, is every basis gamma of V star a dual of some basis beta in V? So this is a question. One way to answer the question is to consider V star star, the dual space of V star. Let alpha be a vector in V. Alpha induces a linear transformation L alpha on V star. So this is sometimes called the evaluation map. So let alpha belongs to V. Okay. We have seen that there exists. We actually defined. We defined if from V to F belongs to V star, such that if alpha is 0, sorry, if alpha is 1, if 0 otherwise. So I mean we defined it in this way actually. F of C alpha is C. I'm talking about the dual of alpha. Okay. But this alpha actually generates a linear functional L alpha on, or maybe you should write the notation on V star. That is, L alpha is a map from the set of linear functionals to F. So how do we define it? Take F belongs to V star. Okay. So F is a map from V to F, right? So what is L alpha F? This is F evaluated at alpha. Do you understand the map? First tell me, do you understand what is L alpha? Alpha is fixed, okay. And we are evaluating every linear transformation at alpha. I mean every linear function at alpha. Sometimes it is called the evaluation map at alpha. Okay. Okay. So hope the map is clear. See, this is a linear map because if you take L alpha of CF, then you see it is CF at alpha, evaluated at alpha. That is nothing but C times F alpha. That is C times L alpha. Again, if you do L alpha of F plus G, you get F plus G of alpha, which is F evaluated alpha plus G evaluated at alpha. which is L alpha F plus L alpha G. So one thing you should you should be able to understand that for any vector alpha, we are sort of seeing them in V star star. So here is a theorem. Okay, but one thing we have to actually we have to prove it that if alpha not equals to 0, then we define a basis beta of V such that beta is alpha, then alpha 1 to alpha n minus 1. Okay, and define, we are defining a linear transformation f alpha like the one we did here. It is from V to F. How it is defined? Uh, Suppose V be a vector in V. V is of the form, say, C alpha plus summation Ci alpha I running from 1 to n minus 1. So if alpha of V basically sends this V to the coefficient of alpha. Okay. So clearly you can actually notice that L alpha of, one thing you can notice is that if alpha of alpha is 1, right? That is clear. So what is L alpha of F alpha? That is F alpha of alpha, that is 1. So if alpha is not a zero vector, L alpha is not a zero element in the V star, is non-zero in V double star. Hope it is clear. So now
উপরে লিখলে এফ আলফা ভি ইকুয়াল টু সি, ওইটা কি লিখলে বুঝলাম না। এফ আলফা ভি ইকুয়াল টু সি লিখে দে।
okay, I am defining it this way. Okay, I should have written
আচ্ছা
it.
আচ্ছা।
See, my goal is to send alpha to 1 and every element which is linearly independent to alpha to 0, right? That's my goal. So I am defining f alpha that way. Okay. So now let's move on to the theorem, where they are saying that let V be a finite dimensional vector space over the field F. For each vector alpha in V, we define L alpha F is F alpha. Okay. For F is in V star. Now they are considering this map. Alpha to F alpha. Okay. So they are saying that if phi is a map from V to V star star, which sends alpha to A alpha, L alpha, is an isomorphism. Okay. So please look at the proof and tell me if you are stuck somewhere. Because if I keep on writing the proof, it will take a whole lot of time. I'll have to complete the syllabus in 6 months actually. Then it will take probably 2 or 3 classes per week for each subject. So this proof I think is understandable. So please go through it. You have 3 minutes. Okay, so the proof is clear, right? Or do I need to elaborate it? Anyone? Shubrita?
আলফা থেকে এল আলফা নন সিঙ্গুলারটা কেন?
Oh, you want to you are asking why alpha to L alpha is non-singular, right? Uh, when is a linear transformation non-singular? A linear transformation is non-singular if it sends no non-zero vectors to zero vectors, right? That's the definition, right? I mean, if and only if
Yes.
kernel is zero, right? Okay. But we have just shown here that if alpha is non-zero, L alpha is non-zero, right? So we have already proved it. Okay. If alpha is non-zero, then the induced map, I mean the induced element L alpha, that is also non-zero. We have shown it because there is a linear transform, linear functional if alpha such that L alpha of F alpha is 1, right? So L alpha is a non-zero vector in V double star. So the map alpha to L alpha is non-zero. Okay. Shubrita, Raghiv, clear? Piyash,
হ্যাঁ দাদা।
Devotion,
হ্যাঁ দাদা।
clear?
হ্যাঁ দাদা দেখ।
Okay. Let V be a finite dimensional vector space over the field F. If L is a linear functional on the dual space V star of V, then there is a unique vector F alpha such that LF is F alpha. See how they have proved the surjection part.
মানে ইনজেক্টিভ হলেই তো সাবজেক্টিভ হবে, ফাইনাইট ডাইমেনশনাল তো।
Yes, but we haven't proved that yet. We haven't proved that V star star is finite dimensional yet, right?
ইনজেক্টিভ এটা তো,
Injective is all right, but V star star
তাহলে
by
তো সাবজেক্ট ও ফাইনাইট ডাইমেনশনাল
yeah.
বলতে
V
পারবো না
star
তাহলে।
star is
ও
may not
আচ্ছা
be
আচ্ছা।
finite dimensional. Okay, but let's see how
So
they are
for
proving.
V for V star being finite dimensional,
Okay, right. Yeah, he's right. So yeah, he's right actually. Dimension V is dimension V star, right? Which is equals to dimension V star of V star, right? That is the dimension V star star. So V star star is finite dimensional because V is finite dimensional, and I mean as a consequence. So this is a very important thing. They are saying that for any linear functional on the dual space of V star, that is, if L is a linear functional from V star to F, right? So L belongs to V star star. So we know that there exists alpha in V such that, I mean, alpha goes to L under the above map. I mean, the map we define to be phi. Phi alpha is L. There exists alpha, right? So what will be L of F? It will be F alpha. Just the way L alpha was defined. I mean, they are saying there exists an alpha such that L is L alpha. That's their point. Okay. So the next thing we do is that let V be a finite dimensional vector space over the field F. Each basis for V star is a dual basis of V. That's beautiful. Read the statement again. V finite dimensional. They are considering V star the dual of V. They are saying that each basis of V star is a dual basis of some V in V. So you can actually understand what they are doing. They will probably take beta star in the basis of beta V star. Now they will be considering beta star star. Understand? So beta star is this. This is beta star. Okay. So of course there exists a dual basis of beta star, beta which is beta star star. That will be like this. Okay. And it will have those properties as well, del ij. But we all know that there exists, from the previous corollary, there exists alpha I such that Li is basically the image of alpha I under that isomorphism, right? That alpha I goes to Li for some alpha I. So Li F is F alpha I. Right? From the above corollary, just the one we did rightly. Here, from this corollary, this line follows that there exists alpha I such that Li F is F alpha I for every F in V star. That is, Li is L alpha I. Okay. It follows immediately that alpha 1 to alpha n is a basis of V. Why? Why alpha 1 to alpha n is a basis of V? Because L alpha 1 to L alpha n is a basis of V star. So what they are doing is the following. They are considering V star, then V star star, and the isomorphism here. So here they have taken Fn1 to Fn. It has corresponded to L1 to Ln. Now we know that this L1 to Ln is actually L alpha 1 to L alpha n for vectors from here, since this isomorphism. Now they are saying that since phi is an isomorphism, phi from V to V star star is an isomorphism sending alpha to L alpha, phi inverse is also an isomorphism, right? So phi inverse L alpha I is alpha I. Since L1 to L alpha n is since this is linearly independent, the image is also linearly independent because of the isomorphism. Okay. Please read these two paragraphs. Okay. AC is any subset of, so probably they have actually formalized the above discussion in this theorem. AC is any subset of finite dimensional vector space V. S not not is the subspace spanned by S. So the proof is the following: W be the subspace spanned by S. Clearly, W naught is S naught. So first line is clear, right? The first line is clear. Is the first line clear? Why W naught is S naught? Suppose S is alpha I belongs to some indexing set, and W is the subspace generated by S. So S is a subset of W, of course, and for that matter, S naught is a subset of W naught is a subspace of S naught. Okay, but if belongs to S naught, then if alpha I is 0 for all I belongs to I mean for any element in S is killed by F, since F is in S naught. But W is a span of S, right? So every element of W, how is it written? W is written in terms of finite sums of psi I alpha I. So f of W is summation Ci f of alpha I, which is 0 because these terms are 0. So f belongs to W naught as well. So S naught is equal to W naught. Okay. Therefore, what we are what we are to prove is that W is W naught naught. Yeah, because W naught naught is S naught naught. You have been told to show that S naught naught is basically W. So they will prove this. W is W naught naught. Do you remember this theorem? The dimension of W plus dimension of W naught is dimension of V. There was a theorem in the previous section that the dimension of W
ডাব্লিউ
plus
নটটা কি হয়েছে? নট ব্যাপারটা কি বুঝতে পারলাম না।
নটটা
নট
হচ্ছে
ব্যাপারটা
annihilator
কি?
of W.
আচ্ছা আচ্ছা আচ্ছা।
I mean all those linear functionals which kill every element of W is denoted by W naught. It is called as the annihilator of W. Okay. But again, they are applying the same theorem here. Like W naught plus W naught naught dimensions is the dimension of V star, but these two are equal, right? So we get dimension of W is dimension of W naught naught. Hence these two are equal, right? Since W is a subset of W naught naught. Is it clear? Why is this line clear? Why W is a subspace of W naught naught? Is this line clear? Let okay. So W is a subspace of W naught naught. Okay, we are claiming this. under the isomorphism. Okay, we already have that isomorphism. So say small w belongs to w. Okay, for any if belongs to w naught, we have if w is 0, right? Right. But if w is nothing but L w of f, right? So it is also 0, where Lw is the image of W under the isomorphism alpha to L alpha, right? So W is contained in W naught naught. This means Lw belongs to V star star actually. So basically W is sort of sitting inside this, under this isomorphism of course. Lw is V star, so Lw is actually regarded as W. Okay. Please read from this to this definition. Please read this. Oof, you have 2 minutes. Okay. So I think we have actually proven it, right? For every for every hyperspace, we have defined a linear functional, and for every linear functional, the kernel was a hyperspace. We did the proof, right? In some of the previous classes, I think we did the proof, right?
Finite dimensional.
Yeah, for the finite dimension, we proved it. Is it same? It's same for infinite dimensional. Yeah, the proof is exactly same. See, the proof is exactly same. See, in both the cases, they are using a very simple fact that image of f alpha, I mean, image of the linear transformation, linear functional, is whole f. So the image has only one vector. It is generated by a non-zero vector. Now they are taking the suppose f alpha is non-zero, then if then every vector apart from alpha is actually, I mean, every vector which is linearly independent to alpha can be considered in the basis actually. See, the trick is the same basically here. For if alpha is not equal to 0, then image of f, which is this, is actually generated by this. Now they are doing the absolutely same thing. The proof is exactly same. How we proved the, go through the proof. I think it is exactly same. If you were stuck somewhere, then let me know. Okay. Have you gone through it? Have you gone through it?
হ্যাঁ দাদা।
Hmm. Okay. Now, okay. So next we do what we do is, if f and g are linear functionals and on a vector space V, then G is a scalar multiple of F if and only if the null space contains the null space of F. That is, if alpha is 0 implies G alpha is 0. The statement is clear. Is the statement clear? F or G are two linear functionals. Then G is a scalar multiple of F if and only if the null space of F contains the null space of G. See, for non-zero linear functionals, actually there is an equality. Okay. This is a lemma and there is proof. Okay. See, the lemma is quite easy. They are saying if f is 0, then g is 0. Then of course the null space is the whole domain. If f is non-zero, so nf is a hyperspace in V. Choose some vector in V such that f alpha is not equals to 0. So alpha is outside f. Okay. Now they are writing C is g alpha by f alpha. The linear functional h equals to g minus cf is 0 on nf. Okay. Since why this is 0 on nf? Because if h of v, suppose you take hv, it is g minus cf of v. V is in nf and this is gv minus c is this, right? G alpha by f alpha into GV. Why is it 0? Sorry, FV. F alpha by FV. Okay. Since both F sorry. G is a scalar multiple, na? Yes, because G and F are 0, na? I mean, G is some, what should I say? Some K into F. So if V is 0, then GV is also 0 on NF. Since both F and 0 are 0 there. Hence, and H alpha is G alpha minus C alpha equals to 0. Do you understand what they are doing? G is some K into F. So GV is equal to K F of V is equal to 0 if V belongs to NF, right? So now they are showing, so what does it mean? This means that H of V is 0 for all V belongs to NF. Then again H alpha is also 0. So H is everywhere 0. Understood? So H is 0 everywhere because, okay, why is it enough to show that a vector, if it's 0 on the kernel of F and outside and 0 on some vector outside it, then actually the linear function is actually 0 because of this. Read this. Okay, that every vector in V is of this form. So if a function, if H is 0 on this and H is 0 on this, then H is 0 on all V, right? That's what they are using. So H is 0. H is 0. H is the 0 linear function, so G is CF. Okay. So it is done. Now they will use this lemma to prove the next theorem, which is the last theorem of this chapter. Just a minute. Let me see whether there is a section after this or not. Transpose of a linear transformation. Should we? Okay, we will think about it. No, this is actually needed. Theorem 20. Let G and F1 to Fr be linear functions on a vector space V with respect to the null spaces n to n1 থেকে nr. Then G is a linear combination of F1 to Fr if and only if n contains the intersection okay. Let's go through the proof. Just give me a minute. So the way they are going about it is like, if first they are doing the like this part, so this part. So suppose G is a linear combination of this. So E, and if I alpha is 0 for all I, then of course G alpha is 0. So N contains this. This part is very trivial. We shall prove the converse, the if half of the theorem, by induction on the number of R. So by preceding lemma handles the case R equals to 1, right? The preceding lemma, as you can see, it was for R equal to 1, right? Suppose we know the result for R equals to k minus 1, and let f1 to fk be linear functionals with null spaces n1 to nr such that n1 to n1 to nk intersection is contained in n. The null space of G. Then G prime, f1 prime, fk prime be restriction of G1 to. So basically what they are doing is that they are restricting G to nk. I mean the kth linear functional, and they are just restricting every linear functional to the linear subspace nk, right? Actually there they will use they will use the induction hypothesis again. Then g1 g prime to f1 prime to fk prime are linear functionals on the vector space nk. Furthermore, if alpha is a vector is nk, and if I prime alpha is 0, then alpha is in this. This means alpha is in this, right? So G prime alpha is always is also 0 because of this hypothesis. By the induction hypothesis, for k equals to 1, there are scalars 1 to c Do you understand what they are doing? They are basically saying this. what is the okay, just tell me one thing. What is the kernel of fi prime? What is the kernel of fi prime? Fi prime is dependent on nk, right? Fi prime is fi restricted to nk, right? So what will be the kernel of fi prime? It will be ni intersection nk, right? So in one intersection nk up to nk minus 1 intersection nk. This is nothing but n1 up to nk intersection, right? So this thing is in n, as this thing is in n. I mean, yeah, such that, so by induction hypothesis, this we can write. Now they are writing h as g, I mean, they are actually using these scalars. They are writing h as g minus this. Then h is a linear function on V, and 3.16 tells us that h alpha is 0. See, h is 0 on nk, right? This is clear, h is 0 on nk, because h restricted to nk is basically g prime minus this ci fi prime, right? Isn't it? What is h restricted to nk? That is g restricted to nk minus summation ci fi restricted to nk. What is that? G prime minus summation ci fi prime. This is 0 from here, right? And also h alpha is 0. Why is h alpha 0? They are saying that 3.16 tells us that h alpha is 0. Why is h alpha 0, by the way? Why is h alpha 0? For alpha belongs to nk. Yeah, no, that I just proved, right? I mean, h restricted to nk is 0. By the preceding lemma, h is a scalar multiple of fk. Okay. Yeah. Now, nk is the kernel of fk, right? So, what are we writing? We are writing that nk is contained in kernel h, because every element of nk is killed by h. So, h is a scalar multiple of fk. Call it ckfk. So, g is like this. The proof is clear? Is the proof clear? Shubrita, Raghiv, everyone? Pritam?
হ্যাঁ দাদা।
অনেকটাই ক্লিয়ার।
There are actually some calculations which you will have to do on your own. Okay. There is a small exercise. Let's see what they are saying. Oh, there are only three problems. I think we can do it now. So let's try 1, 2, and 3. Let's try. Try 1 first. You have 2 to 3 minutes. Try 1. Hello. So what is the problem? In positive integer field, if W be the set of all vectors x1 to xn such that the sum is 0, prove that W not consists of all linear functionals if of the form show that the dual space of W star of W can be naturally identified with the linear functional this. See, my first instinct having this problem is just this is called the sum vector. I mean 1 comma 1 comma 1. So if you consider this vector 1 comma 1 comma 1, so what do you get? I mean, define this linear functional. Oh, we haven't come across inner product yet, sorry. So prove that W not consists of all vector f such that okay, so this is a subspace, I mean W, right? So dimension W is n minus 1. This implies there exists f belongs to V star such that nf is W, right? Now they are saying that prove that W not consists of all linear functions f of the form this. So let G belongs to W naught. Okay, they are writing f here, so we should write maybe G here. So f kills every vector in W. Okay, so let V1 থেকে Vn.
ওই জি বিলঙ্গিং টু ওই আগের লাইনটা কি করে হলো? দেয়ার ইজ জি বিলঙ্গিং টু ভি স্টার সাচ দ্যাট এন জি ইকুয়ালস টু ডাব্লিউ।
Didn't we just prove it that for every hyperspace there will be a linear functional? This theorem. Okay, W is a hyperspace, right?
ঠিক আছে।
Okay. So suppose f belongs to W naught. So for any belongs to W, we have summation Vi is 0. You already have it, right? But according to them, this is supposed to be 0. They are saying that this is a scalar multiple of this thing. Okay. I think we should be try to we should try to prove it in this way. If x1 x2 xn is c summation xi j running from 1 to n, then f belongs to w naught. It is true that, right? Because if x1 x2 xn is in w, then summation xi is 0. So f of this is 0, so f is in w naught. So one part is obvious, right? I mean, if f is of this form, so if f is of the form of that form, f belongs to w naught. We will prove the opposite, that if, so let's prove that if f belongs to w naught, then f x1 to xn is summation c into xi, I running from 1 to n. Okay, we will prove it. So how should we approach, Rahul? Suppose c is not of this form, then
I think we evaluate on the standard basis. What will be the form on the standard basis?
actually W naught is a random substance. I mean, should it have a standard basis? Does W naught have a standard? I mean,
দাদা,
hmm,
যদি ধরে নিই ওই কোএফিসিয়েন্ট গুলো মানে C1 থেকে সি মানে CN করে ধরে নিই,
hmm,
মানে সি যে সেম নয়, তারপর যদি এমন ভাবে x1 মানে এই টাপেলটা এমন ভাবে চুজ করি x1 থেকে xn, মানে 1 - 1 0 0 0 0 সেটা জিরোতে যাবে,
hmm.
তাহলে এইরকম ভাবে যদি এগোতে থাকে তাহলে প্রত্যেকটা কোএফিসিয়েন্ট জিরো মানে সমান হয়ে যাচ্ছে C1 থেকে CN, তাহলে কি?
No, okay. No, but there you are using something actually. You are using the fact that f of x1 to xn is of the form summation some ci xi,
হুম,
right?
হ্যাঁ,
But
ওটা ধরে নিয়ে এগোতে হচ্ছে, না হলে হচ্ছে না।
we haven't
হুম,
yet proved it, right? Have
হ্যাঁ,
we proved it?
প্রথমে চ্যাপ্টারের প্রথমে একটা
I know that I had stated it, like Rees representation theorem. But did we prove it? Because I think we need to use inner product to prove it. But have we proven it? তিয়াশা এটা proof করেছি নাকি? I think we stated it, but did we prove it? Oh, just a minute. Let me see whether there was a theorem in this. Linear functional, when is that? No, I don't think we have. They are saying that a typical
কিন্তু
linear.
থিওরেম 15 কি এনাফ নয় ওই ফর্মটাকে বলার জন্য?
Theorem 15.
হুম।
Uh, No, actually the point is that we haven't yet introduced inner product, so we can't actually product things. Okay, but I think we can use this actually. For f to the power n, I think we have the dot product, right? So for f to the power n, it is good enough. Like the one I just underlined somewhere here.
97, page number 97.
Hmm, 97.
Every linear function alone, Fn.
Yeah. Okay, so every linear function on Fn is of this form. Yeah, she's right. So here also we are defining a linear function on Fn. So here also we are defining a linear function on Fn, right? Fn. So it is of this form. She is saying that, say, if we know that if f belongs to if n star, then there exists c1 to cn belongs to f such that f of x1 to xn is summation ci x to the power I, right? Now we have to prove that every, see, what is your goal? Your goal should be, we have to show ci equals to c for all I belongs to this for some c, right? We have to prove that every ci is equal. Now see, choose this vector. Okay, so what is that? This is c1 minus c2, right? And this is in w, so this is 0 since f belongs to w naught. This implies c1 equals to c2. Choose this vector belongs to w, then f of that vector is c2 minus c3. This is equals to 0. This implies c2 equals to c3, and so on. Okay, so you can do it. Is it okay?
Yeah.
But could we have done it without using it? Like, suppose c minus xi minus. Okay, they are saying that show that the dual space w star of w can be naturally identified with the linear functionals this. So they are saying that, I mean, just like V in V star, W has a dual in W star. So they are saying every linear functional there should be like this. So let if belongs to W star, then F should be of this form. According to them, F should be of this form. So let C1 to Cn be in W. Okay. So we have, call it let's call it gamma. We have L gamma in W star, right? So f of C1 to Cn should be L gamma of f if is in W star. No, I think I have messed something up. If is in W star, I think I should have written it this way. If is in W star, so take the dual of f, right? Like if how should I write it? Like if star is in W star star, right? Do you understand what f star is? Do you understand what f star is? Like the dual basis, I mean, if star is from W to F is of this form. Like if star of C of F is C. You understand the way we just defined like alpha belongs to V, then F alpha we defined like this should be like this, right? So this F star is basically the dual of F, like the F alpha was the dual of F, the dual of alpha. Okay, but there exists gamma belongs to W such that L gamma, such that L gamma and gamma are corresponding to each other, right? So L gamma of F is F of gamma write gamma as this C1 to Cn, F of C1 to Cn what was like naturally identified with the linear functionals. Uh, we are actually trying to do W star, right? W star. Okay, see today it's 12:10 today. So Rahul, let's complete it and send it in the group, okay?
Okay.
And do 2 and 3 at home. Otherwise, we will discuss it in the next class. Try it. If you don't do it, then actually I will do it in B. Actually, this is 12:10. This is actually pretty simple. This is very very intuitive. In fact, somehow I am missing the calculations.
আগের দিনের একটা প্রবলেম
হ্যাঁ
incomplete
Student?
codes.
Oh, now baki আছে না? See, there are some problems which will be actually will remain incomplete. So what we do, collect all those unsolved problems which were not actually solved in the class, like which were tried but we were stuck somewhere. Send that collection to me, then I can actually try it in my off time. But actually, it's impossible for me to keep track of the problems that actually were not solved in the class. So I'd request you to actually keep a track of it and send me a copy which actually mentions those problems. Okay.